quadratic equations, but not every is a nice way to solve quadratic equations, but not every equation so we need some other technique. And so the square root property provides a technique that we can use. The square root property provides a technique that we can use that we can apply. But if we don't already have a perfect square that we can apply, in that case, we can't really use the square root property in that case. So there's a technique called any quadratic square equation that allows us to quadratic create a perfect square and then apply the square root property. Create a perfect square and then apply the square root property. The general principle here. So let's take a look. If we have an expression and we're looking at a slightly specialized expression where I have 1 as the value for a, so there's nothing in front of the x squared, and so we could put a 1 there, but in general we just leave it empty. So I have x squared plus bx plus c equals 0. Then what I'd like to do is move c to the other side. So I'm going to change this into x squared plus bx equals negative c. And then I'm going to put a special value here. I'm going to add a special value to both sides. And the value that I'm going to add is b divided by 2 squared. So I'm going to add that to both sides of the equation. So that gives me x squared plus bx plus b divided by 2 squared equals negative c plus b divided by 2 squared. Right, so in order for the equation to remain true and equivalent to what we started with, I need to add that amount to both sides of the equation. When we do that, then this side of the equation, somewhat magically, but algebraically at least, and that's a little bit like magic, so this side of the equation factors into the expression x plus b over 2 squared. And that works because b over 2 plus b over 2 is exactly equal to b, and b over 2 times b over 2 is equal to b over 2 squared. So this may seem a little confusing at this point, but let's take a look at a couple of examples to see how it works. First, let's just look at some binomial expressions of the form x squared plus 6x and think about what number could I add, what would be the special number that I could add to that to create a perfect square trinomial. So in this first example, the value of b equals 6, and so if I divide that in half, b over 2 is equal to 3. But then the thing that I want to add is b divided by 2 squared, so 9. And it turns out that that expression then, if I add 9, that expression is equal to x plus 3 squared. In the second example, sort of in a similar way, the value of b that we have is 7. So b over 2 squared is going to be 7 divided by 2 squared, and 7 times 7 is 49, 2 times 2 is 4. So if I add 49 over 4, then that trinomial now would be equal to, it factors as m minus 7 over 2 squared. So with those examples in mind, let's take a look at the following equation and try to solve it by completing the square. So to complete the square, the first step, I'd like to move the constant term that's there to the other side. So the plus 13 becomes a minus 13 on the other side of the equation. And now I want to think about what number can I add here, and then because it's an equation I need to also add it to the other side. What number can I add to both sides to turn the left hand side into a perfect square trinomial? Well, b is equal to 8, so if I divide that in half I get 4, but then I also want to square that, and 4 squared is 16. So I want to add 16 to both sides. So that gives us x squared plus 8x plus 16 equals positive 3. Because negative 13 plus 16 is 3. And now 16 was a really great choice because this side now factors, the left-hand side now factors, and not only does it factor, but it factors as a perfect square. Because 4 times 4 equals 16, and 4 plus 4 equals 8. So the left-hand side now factors as x plus 4 squared, and the right-hand side is just 3. I can apply the square root property because I now have a perfect square on the left-hand side, and that gives me x plus 4 equals plus or minus the square root of 3. And to finish our solution, we simply need to subtract 4 from both sides. So the values for x that make the equation true are negative 4 plus the square root of 3 and negative 4 minus the square root of 3. I encourage you to take a few minutes and try to solve the following equation. Y squared minus 10y plus 43 equals 0. And try to solve this by completing the square. I hope you enjoyed the video. Thanks for watching.